Hello, dear friends, my dear students. I am once again here. Lalitkumar P. Bhaiya is going to deliver a lecture on digital signal processing. This particular lecture is for BE Electrical 6th semester students as well as the electronics and telecommunication students. Today we will discuss about this digital signal processing and processor both. Let us see here what are our learning objectives. We want to know why we process signal digitally. Definition of real-time application. Why use this digital signal processors, DSP, digital signal processing processors? What are the typical DSP algorithms? Parameters to consider when choosing a DSP processor. Programmable versus ASIC DSP. ASIC means Application Specific Integrated Circuits, DSP. And Texas Instruments TMS320 family. TMS320 is one of the most popular DSP processor. Why go for the digital? Digital signal processing techniques are now so powerful that sometimes it is extremely difficult, if not impossible, for analog signal processing to achieve similar performance. That is why we go for the digital. With the help of the digital, we can achieve the signal processing very easily as compared to analog signal processing. For examples, the finite impulse response filter with linear phase and adaptive filter. These are the two best examples of the digital signal processing. Analog signals processing is achieved by using the components. These components are most popularly resistors, capacitors and inductors. The inherent tolerances associated with these components, temperature, voltage changes and mechanical vibrations can dramatically affect the effectiveness of the analog circuitry. With DSP, that's why we use the DSP here. With DSP, it is easy to change the application, correct the application, update the application. Additionally, DSP reduces the noise susceptibility, chip count, development time, cost and power consumption. This is the benefits of the digital signal processing. Why not go for the digital? Like high frequency signal cannot be processed digitally because of the two reasons. Analog to digital converters, that is ADC, cannot work fast enough. Similarly, the applications can be too complex to perform in real time. What do we need DSP processors? What do we need the DSP processors? What do we need the DSP processors? You can see here, why not use a general purpose processors? General purpose processor means microprocessors such as Pentium instead of DSP processor. What is the power consumption of a premium Pentium and DSP processor? What is the cost of the Pentium and DSP processor? These are the points why we go for the DSP processor. Use a DSP processor when the following are required: cost saving, smaller size, low power consumption, processing of many high frequency signals in real time, use of GPP processor, general purpose processor, when the following are required: large memory. When large memory is required, we can use general purpose processor, advanced operating systems. And now this is the important. What are the typical DSP algorithms? The sum of products is the key element in most DSP algorithms. Here you can see the finite impulse response filter, of which equation is given here. This is used for FIR filter. This is for the IIR filter, infinite impulse response filter. This is the equation that we will learn ahead: convolution, then discrete Fourier series, and then discrete cosine transform. These are the basic algorithms which uses the DSP, digital signal processor, or in case of the digital signal processing. Hardware and microcode multiplication. DSP processors are optimized to perform multiplication and addition operations. Mainly here the convolution is used, and convolution requires the firstly product and then sum of all the products. This type of applications, this type of calculation is required in the DSP. That's why DSP processors are optimized to perform the multiplication and addition operations. Multiplication and additions are done in hardware and in one cycles. Like this example is shown here. We will not go for this example now. This is the example shown here. So we don't need now this one. This is floating versus fixed point processor. This is also we don't need here. We will go now in the next slide, the DSP, FFT and all other applications of the DSP. Thank you very much. You can read more and more books on the DSP. Lot of books are there. Shali Vahanan and Mitra, the digital signal processing by with a computer. It is available in the library also. Thank you very much.